So, have you ever wondered how a computer is programmed to complete the tasks that you give it? Well, the process of coding and programming a computer to complete a set of tasks is called programming logic. Programming logic is the process of coding and programming the computer to follow a set of instructions and carry it out. Now, before we go to the next slide, there's going to be an activity, so can everyone please stand up? And you'll have 30 seconds to arrange yourselves by birthday, January over here, December over here, and no talking. 3, 2, 1. Seconds. Alright, okay, so as you can see, that might have been hard without talking. So now we're going to do it again, but this time you can talk, and December will be over there, and January will be over there. Alright. Today.
I'm January 9th.
October 9th, May 3rd, September 3rd, May 3rd, May 3rd. I'm January 20th.
Okay, are you guys all done?
Yeah.
Okay, so as you can see, once you got to talk, it's a lot easier. And that's just like how programming logic helps computers like simplify equations, and it just adds a little bit more help. Also, if you see the red, green, and yellow cards on your table, red means if you lift up your red, that means you have no idea what's going on, and so we'll help you re-understand that concept. Yellow is I kind of get it, and then green is I understand it completely. All right, you can get back to your seats. Programming logic is the code that is used to give a set of instructions to a computer to follow and carry out. It involves decomposing issues into smaller tasks for it to be able to complete easily and formulate a plan of action. It uses logical rules and structures to achieve the desired outcome, and it's essentially about how a programmer thinks and approaches problem solving in a way that can be translated into code. According to Stanford, there are two main types of programming: imperative and declarative. Imperative programming focuses on how a task needs to be done and how to code it step by step, while declarative programming focuses on what needs to be done and describes the outcome without specifying the explicit instructions on how to code it. Imperative programming uses loops and conditional statements to modify variables easily and control the desired outcome, while declarative programming focuses on using different statements to describe the desired outcome and the relationship between inputs and outputs. According to Linode.com, within these two categories, there are still many other subcategories which we will not be able to teach today, but some examples include C++, Java, SQL, and many others. There are 4 basic key concepts of programming logic: sequence, selection, loops, and functions. Sequence is the order in which instructions are executed. This is crucial to maintain the sequence for a program to be able to produce the desired outcome. Selection, also known as conditional statements, allows programs to produce different paths of execution based on different inputs. For example, an if-else statement determines whether to execute one code or another. So this is important because it allows programs to be dynamic and respond differently to different inputs. Iteration, also known as loops, involves repeating a block of code multiple times throughout a program until a certain condition is met. For example, a type of loop called a for or a while block will repeat a block of code until a counter will reach a certain value or until a condition is no longer true. This is crucial for automating repetitive tasks and creating easy-to-use and functional programs. Finally, the last one is function. When a code is required to be reused multiple times, it's called function. Instead of needing to write the same code repetitively, a function can be executed anywhere throughout the program.
Alright, there are many examples of programming logic in the real world, and the first one that I wanted to talk about was AI. So artificial intelligence uses programming logic to learn and create new responses and to use the keywords that are spoken to it to find the information that's needed. Another example that uses programming logic is natural language processing, or NLP. And NLP is the interaction between computers and humans. Programming logic helps create user-friendly responses, and it helps just the interaction between computers and humans just to be easier. And then finally, there's database management, where programming logic helps find the best way to store information and find stored information a lot quicker than it would without it.
Right, so these are two of the most common mistakes that are made when learning programming logic. And the first one is called an infinite loop. So an example on the right, we have a block of while code. So it states that while I is less than 5, print I, and in this case I is equal to 0. But what this block of code is missing is a changing condition that changes the value of I. So the condition that I is less than 5 will always be true, and it will keep printing it over and over again, thus the name infinite. And the second one is called an off by one error, and this occurs when a loop starts or ends at the wrong index. So in the example on the right, we have 3 names, Alice, Bob, and Charlie, and the code is basically saying that for the names in the range of index 1, you print the names. But for Python, index starts at 0, so skip over Alice and only print the names Bob and Charlie. So both these mistakes show how small logical errors can cause big problems in coding. And these are 3 of the benefits of actually learning programming logic. The first one is that it helps you break down problems. It improves your problem solving. So when you're learning programming logic, you're basically breaking down a big block of code into smaller steps and logical steps. And number 2 is that it reduces your coding errors. So if you have a strong understanding of programming logic, you're less likely to make mistakes. And third is it overall makes your code more cleaner and organized and easier to read.
Okay, so the Google Forms that we had you fill out, it really helped us find what we needed to put in our speech to teach you more about programming logic. About 23% of you got, which is not a programming language, correct. It was HTML because Pascal, Basic, and Python are all types of programming logic. On the select all that are key elements of programming logic, most of you got it correct. Only a few of you clicked quantifying or anomaly, which are clearly not key elements. And it's clear that looping, selection, and sequencing are. Now, some of the responses that we got for the free response question, how does programming logic help simplify simulations and the way computers function? One of the responses we got was it acts as a bridge between binary and normal writing languages, making it easier for programmers to instruct computers. This was a perfect response, and it really answered the question really well. One of the responses we got was it takes up less space on a computer. While that was pretty close, it's not completely what we needed. And then the third response I saw was it helps the computer better understand what it has to execute. And that was pretty close, but it was not all the way perfect. But anyway, from this question, we learned that you guys did really good with a basic understanding of programming logic, and that we didn't have to teach you a lot on the basics.
Alright, so now it's time to play Kahoot. So that's the code. Alright, and so once everyone's in, you can just start it. question is, what is programming logic? Okay, good job. So sequence is what? Good job, that was pretty good. What are the 5 main types of programming language? What is loop? All right, last question.
I'll read.
Okay, good job.
Good job, Kavya, Mackenzie, and Azalea.
All right, in conclusion, programming logic is pretty much the core of all coding. And without it, codes will break easily, and it will result in bugs, crashes, and wrong results. It helps us think in a structured and problem-solving way, and it's also useful just beyond coding, in projects, fixing things, and decision-making. Overall, it makes you a strong thinker and not just a better coder.